I'm starting a new series for PLC because PLC is very important in automation and robotics. See what PLC is, how the structure of the PLC is. Well, let's start here. Imagine there is a conveyor belt here. So you have a conveyor belt here, and then here it's going to be forked, and it goes this way. So here you have pink balls and blue balls coming in, and you want to separate them. You want to send all of the blue ones here, and you want to send all of the pink ones here. Well, there are multiple ways that you can do this. One of the ways is manually. So whenever a ball comes here, if it's blue, you just push it this way. You just push it this way, and then when the pink one comes here, you just push it this way. So this way you're going to separate the balls. So the problem with this is, first of all, is manual labor, because somebody have to sit there and separate these two from each other. One is not cost effective because you actually need a person to sit there and separate these two balls from each other. Second thing, if you're doing it manual, there might be more mistakes than if you automate it. In some situation, it is more safe that a human wouldn't be around the area. Okay, so we can automate this. So the machine have to make a decision if it has to let the blue ball go or if it has to push it to the other way. When you want to automate the system, you do it with some sort of controller. This controller system have a processing unit, so it will go through the instruction, and based on those instructions, it will make decisions. So it has information coming in. So for example, here we might have, because we want to know about the color, we have a sensor here that senses the color of the ball, and then this information is sent to the microprocessor that goes through the instructions and the information that it is receiving from the input. In this case is a sensor, and then it will make a decision to, for example, move the arm. If we have an arm here, if there's an arm here to push the ball down, it will make a decision to move the arm or not move the arm. And in this case, this is called actuator. Actuator will get the signal from microprocessor, and if the ball was pink, it will push it forward. So that means that the signal changed into a movement, and it will move the pink ball to the other way. Another thing to keep in mind here is that you might have this question that there are so many different types of controllers. Why are we focusing on PLC here? One of the most important reasons that PLC is used in industrial settings is that it is durable. Because in industry, you might want your system to run 24/7, or maybe it is very humid, it is very cold, or it is very hot. PLCs are built in a way that can withstand these type of environments. So they are good for industrial settings. Now let's take a look at the structure of a PLC. So if this is the PLC, we have inputs coming in. These inputs can be switches or different types of sensors, anything that gives information to the processor. So these are inputs. And we have output. These outputs are called actuators as well. You're gathering information from the environment, either with switches or sensors, and then these information are going in the processor, and based on the program that they have, they will make decision that what should be happened. So the output is going to react accordingly. And in this case that we are talking about, this sensor that senses the color of the ball is going to be our input, and it will sense if it is blue or if it is pink. And then the program here is, if it was blue, let it go. If it was pink, push it out of the way. If you want to translate what's happening here into this logic, we are having a sensor, which is an input here. This sensor can tell if the ball is blue or if the ball is pink. This sensor sends the information that this ball is blue, this ball is pink. So now processor have this information from the environment. Based on the logic, the program that it has, it says that whenever you see blue, just let it go. Whenever you see pink, move the actuator, and then send a signal to the output, the actuator, and actuator will move. One of the things that we have to keep in mind is that this controller, PLC itself, for sending a signal, it doesn't need that much voltage. But then some of the actuators that it has, like for example, if it has a very big motor, In order to protect the system, they isolate these two circuits because they require different type of voltage. You have your circuit isolated, which is very important actually, because if you are working in an industry and some of these actuators use very high voltage, if something goes wrong or anything that happens, then your PLC is not going to get destroyed because it wasn't actually in the circuit of the high voltage. It has an LED here. This is coming from the PLC side. And then you have a sensor here. So this is a photo sensor, and this is part of its own circuit, and this is part of its own circuit. The only thing that happens is that PLC is sending a signal, and the LED lights up. This photo sensor picks it up and turns on the other circuit. So yeah, this is the basic idea behind the PLC. To recap, a PLC is a controller unit, and it is used in industries because it can withstand harsh environments. Some of the most important parts of it are inputs, the sensors, and the switches. All of these inputs gather information about the environment. There's all of these instructions or the program. And based on the instruction that it has, it will make decisions and send a signal to the output. So these gather information and these do the actions. The outputs can be alarm, it can be a motor, it can be any type of actuator. And then for protecting the system, and then for protecting the circuits against high voltages, because again we're talking about industries, we are using photo optics. So these are the main parts of the PLC, and this is what PLC is. And in the next video, I'm going to talk about the logic gates.